Welcome to the channel, everyone. Today we are exploring the concept of immutability in C#. It may sound a bit fancy, but it's simply a way of creating objects that cannot be changed after they are created. First, we'll discuss immutable objects, then we will talk about immutable collections, and finally, we will cover record. So, without further ado, let's get started. Firstly, let's discuss immutable object and immutable collection. In certain situations, you may require an object or collection remains consistent throughout its life cycle and cannot be altered after creation. This immutability ensures predictability and safety as they can't be changed. Let's take a look at how they are implemented in C# code. Imagine a class representing a person. In this model, I can change the person's name. So let's see how to make it immutable. Let's revert to the traditional constructor. One solution is to initialize a field in the constructor and return that field. In this case, the property is read-only because there is no setter for the property, but I can have a method to change the person name internally, which is wrong, as when an object is immutable, we should not be able to change it internally or externally. One solution is to use a read-only keyword. By using read-only, we can initialize the property only once and there is no way to change it afterward. However, it may involve a lot of code. Is there a simpler solution, you might ask? The answer is yes. Let's change the property to the default format and remove the constructor. Let me remove it. We can use the init keyword to initialize the property only once. The syntax will be cleaner and smaller. As you can see, right now I can initialize the person name only once and there is no way to change it afterwards. But for demonstration purpose, let me add a primary constructor again to show you the same code as before. But is this the only way to write an immutable object? The answer is no. Let's also take a look at the record. It is a special kind of class specifically designed for holding data. They come with immutability, so you don't have to worry about accidentally changing them. Plus, records automatically generate boilerplate code for things like equality checks, making your life a whole lot easier. They are perfect for scenarios like DTOs or configuration settings because they are not supposed to change. For instance, here I'm going to create a record class for a person. As you can see, it's much slimmer than the person class with exact same properties. The only difference is that it's record and immutable by default. Let's see what is compiled because they're exactly like each other. By using record, a lot of boilerplate code has been generated for us. For instance, it inherits from the immutable interface. We have a backing field for the name property along with additional code for clone. But for the class, the generated code is just a backing field for the name property, and that's it without a lot of boilerplate code for comparison and stuff like that. But in records, we have a lot of boilerplate. For instance, let me create two person. In the realm of reference type, we know there are two separate things, but here they act like a value type, so they are the same because they have the same value. In some scenarios where we just need to change something, we can use the with keyboard. Let's see what is with doing. At compile time, it will call the clone method, which creates a new instance of class as it's immutable and cannot be changed. So here, as you can see, the clone method will be called and a new reference of the previous record will be created. Let's discuss immutable collection. I have a person which is a record and it's immutable and a collection of a person. But right now I have mutable collection of a person that can be changed. How can I make it immutable? One approach is to convert it to enumerable, which does not have any add or edit method. Make it suitable for scenarios where only one iteration is needed. As you can see here, the result is 2, and there is only one iteration. However, what can we do when we need to iterate over more than one time? In such cases, we can use iRead-only list. As it's read-only, you can't add or edit anything to the collection. As you can see, it implicitly converts to a list because it inherits from the iRead-only list interface. But how can I make it immutable? Right now it's just read-only. I can use immutable list type and call .toImmutableList method to make the collection immutable. I wouldn't expect to have an add method or edit, but surprisingly, I do have an add method. Please ignore the Copilot generated comment. Is it really going to add anything to the list? The answer is no. If I write the code in the console, and as you can see, there are 2 people on the list. Let me run the application for confirmation. And yes, as you can see, there are just 2 people. What happens is that the add method is exactly like a with keyword in the record, and it creates a new object because it's immutable. As a result, the new list has 3 objects. I should mention that we have another types too: immutable dictionary, immutable list, and so on. So that's the basic idea of immutable object and collection in C#. That might seem a bit different at first, but they offer a powerful way to write cleaner, safer, and more predictable code. Alright folks, that's all we have time for today. If you enjoyed this exploration of immutability, be sure to hit that subscribe button. Until next time, happy coding!